Hey class, we're going to look at some trig integrals on this video, specifically the ones involving sine and cosine. At the very top of your screen, I put in one of the Pythagorean identities that you can find on your trig identity sheet in Google Drive. One of the more famous of the three is sine squared theta plus cosine squared theta equals 1. If you were to manipulate this by subtracting either sine squared or cosine squared on both sides, you would still get a legitimate Pythagorean identity, just in a different form. Some of the integrals in this section, we're going to have to use a variation of that original Pythagorean identity. So when you're integrating sine and cosine integrals, and you'll usually have one of each with multiple powers, if sine or cosine, and it doesn't matter which one, if you find one with an odd power, just set one to the side and it can be used as your derivative substitute. So let's jump into an example. Of course, I'm not going to jump in just super complicated at the beginning, just to give you an idea of what's going to go on. We have the integral of cosine to the 7th power x times sine x dx. They're both actually odd, so at this point you could set either a sine or a cosine to the side and just kind of leave it hanging on the end. Because sine already has a power of 1, I'm just going to choose to leave that one to the side. What I'm going to do here is I'm going to let u be cosine of x. And taking the derivative, you'll get negative sine x dx. Which has exactly one of the signs left over from the original problem. I'm going to move the negative over with the du side, so we'll have negative du equals sine x dx. Okay, so when you go back to the main flow of the problem, we're going to have negative integral u to the 7th du, which will have a friendly antiderivative. Add 1 to the power, divide by the result. Plus c. And then we bring cosine x back in for u. Okay, now with trig functions and powers, you can either write that 8 directly above and in between cosine and x, or you can do it outside the parentheses. Here would be the alternate way, and it's just as correct. It's totally up to you which way you write it. Either one's just as good as the other. The next example is going to be a little bit more involved. We have the integral of sine cubed of 3 theta times the square root of cosine 3 theta, D-Theta. I noticed that the sine function in the front of the problem has an odd power. And so what I'm going to do is I'm going to just attempt to use cosine 3 theta as my substitute, because the derivative of cosine involves sine. But first, before we get into that, let's rewrite that. I'm going to split that sine cubed up into a sine squared and a sine to the 1st power. So everything's there, it's just split up into 2 and 1 instead of 3. Under the radical, we have cosine 3 theta. That's what I'm going to choose as my substitute. If it doesn't lead anywhere, I mean, you can always start over. That's the good thing about math. If it gets too boggy, you can always start over, start fresh. The main thing is whatever you set to the side, that odd power, that needs to be the derivative of your substitute. Using chain rule, we're going to get a negative 3 sine 3 theta. Divide both sides by negative 3. That's negative 1/3 du equals sine 3 theta d theta. And now I believe we're ready to jump in and start working on the integral. From the Pythagorean identity on the first slide, sine squared can be replaced with 1 minus cosine squared. Square root of cosine 3 theta. Sine 3 theta d theta. Now let's put the substitute in. Everywhere there's a cosine 3 theta, we're going to put a u, and our derivative line, sine 3 theta d theta, can be replaced with negative 1/3 du. Let's do the substitution and see how this starts looking. One minus cosine 3 theta squared, we can write that as u squared. Square root of cosine 3 theta, that can be u to the half du. Multiplying through, we had 1 minus u squared in parentheses times u to the half. If we distribute u to the half, that gives us u to the 1/2 minus u squared times u to the half is u to the 5/2. Just add the powers. Now we're ready to start taking antiderivatives. One half plus 1 is 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So there's our first antiderivative. 5/2 plus 1 is 7/2. Dividing by 7/2 is the same as multiplying by 2/7. Distributing negative 1/3. Negative 1/3 times negative 2/7 is positive 2/21. And then our u will get replaced with our original substitution, cosine 3 theta. Now again, if you want to write that 3/2 above cosine but not past the 3 theta, that's totally up to you. Whatever you feel more comfortable with. This is just one of the two ways you can write it. And there's our solution. I will write it the other way just again so you can see, and you pick which way you prefer. And for our third example, we're going to look at the integral of cosine to the 5th x over square root of sine x dx. On this one, I noticed that cosine's got an odd power. I'm going to set one of those to the side, and then we'll use sine x as our substitute. We've got them all, so that's all that matters, is trying to find one with an odd power, setting one to the side, let the others stay grouped together. Cosine to the 4th is the same as cosine squared squared. Property of exponents. Okay, so now you can see the cosine x dx on the end. If we let sine x be our substitute, its derivative is just by default and definition cosine x dx. Okay, so let's move to another slide where we've got more room to work. Continuing, okay, so from Pythagorean identity, cosine squared is equivalent to 1 minus sine squared. I'm going to go ahead and rewrite the radical on bottom with a power of 1/2. Keep in mind that sine is our substitute, so everywhere there's a sine x, we can put in a u. Even if it's squared, we'll just put a u squared. Our derivative line was cosine x dx, and that can be rewritten with a du. Foiling the numerator, bringing u to the 1/2 to the numerator, distributing u to the negative 1/2, be very careful to add negative half to those existing powers. Now we're ready for the antiderivative of each term. Excuse me. And that's where we're going to add 1 to the power, divide by the result. Negative half plus 1 is positive half. Dividing by half is 2. Three halves plus 1 is 5 halves. So that'll be like multiplying by 2/5. Seven halves plus 1 is 9 halves. So that reciprocal is 2/9. Plus your constant of integration. And now we can go back in, and everywhere there's a u, replace it with sine x. Your preference on how you write that exponent. And I hope this helps.